In this video, we'll be exploring geometry and measurement, which in grade 7 includes investigating circles. After we learn some more about circles, we'll be able to solve an interesting problem like this one, which considers the distance around a glass. So, let's explore circles and learn some important vocabulary. A circle has a center. And what defines a circle is that every point on the edge of the circle is the same distance from the center. A line through the center that goes all the way across is called a diameter. If the line goes from the center to the edge, it is called a radius. As we can see, a diameter will be twice as long as a radius. Here are two more things that we can measure on a circle. First, the measure of the length of the edge of the circle, meaning the distance around the circle, is called the circumference. Area refers to how much space is enclosed within the circle. Let's begin by exploring circumference. One way to measure the distance around a circle is to take a piece of string and wrap it around the circle. Then we can straighten the string and measure the length with a ruler. Let's measure several different circles this way. For each circle, we'll measure its diameter and its circumference. We'll then record these measurements in a table. Our first circle has these measurements. Next, a smaller circle, followed by another circle, and finally, one more circle. If we were to plot these values on a graph, the points would form a straight line. This indicates there must be a special relationship between the circumference and the diameter of a circle. But what is this relationship? Examine the table and see if you can figure out how the circumference is related to the diameter. You may have noticed that for each circle, the circumference is around 3 times the diameter. So let's add a third column to our table and calculate the circumference divided by the diameter. Because the measurements are approximate, the quotient won't be exact. But notice they are all about the same. In fact, the precise value is 3.14159 followed by infinitely many digits. Recognize this number? It's pi. So pi is the number we get whenever we divide the circumference of any circle by its diameter. For this video, we'll use a value of 3.14 when doing calculations. We can also represent the relationship using a fraction, and then by multiplying both sides of the equation by d. We get the formula that circumference is equal to pi times the diameter. Let's apply what we have learned about the circumference of circles with a few examples. Let's begin with the cup that we had at the beginning of the video. This cup has a height. Let's also consider the circumference of the cup somewhere in the middle, which we could measure with a piece of string. Which of these two lengths do you think is longer? What do you estimate? First, let's show the answer to this problem visually. We can unwrap the string and compare it to the height of the cup. What may come as a surprise is that the circumference is significantly longer. Let's confirm our solution by doing some calculations. Suppose this cup has a height of 20 centimeters and that the diameter of the circle going around the cup is 10.4 centimeters. The circumference is pi times the diameter, which is pi times 10.4. Using a calculator, this gives that the circumference is about 32.7 centimeters, which is greater than 20. So the string going around the cup is longer than the height of the cup. In our next example, we'll determine some unknown values. Here are two circles. The first has a radius of 9 centimeters, but the circumference is unknown. The second has a circumference of 21 centimeters, but the radius is unknown. How can you figure out what these unknown values are? Let's look at the first circle. The circumference is equal to pi times the diameter. Now we have not been given the diameter, but we do know that the diameter is double the radius, which means the diameter measures 18 centimeters. So the circumference is pi times 18. Using a calculator, this product is 56.5 centimeters. Looking at the second circle, once again, we have the circumference as pi times the diameter, which is given as 21 centimeters. We can divide both sides of the equation by pi. So the diameter is equal to 21 divided by pi, and this is approximately 6.68 centimeters. The diameter is double the radius, so the measure of the radius is half of 6.68, which is 3.34 centimeters. For our final example, we have a track that is surrounding a grass field. The perimeter of the field is 300 meters. The straight line part of the track is 100 meters long. Given this information, how can you figure out how wide the field is? The perimeter is 300 meters, but 200 meters is taken up by the straight sections. So if we subtract the straight sections, we are left with 100 more meters of perimeter. That is made up from the circular parts of the track. In fact, these two parts join to make one complete circle with a circumference of 100 meters. Its diameter represents the width of the field. Applying the formula, pi times d equals 100. So d is 100 divided by pi, and that is approximately 31.8 meters. So the width of the field is 31.8 meters. Next, let's explore the area of circles, which, as you may recall, is a measure of how much space is enclosed by the circle. To discover a relationship that allows us to calculate area, let's begin by dividing the circle into 4 wedges. Next, we'll arrange the wedges like this. As we look at this new shape formed, let's define the bottom lengths as b and the height as h. How do the values of h and b relate to the circle? The bottom part of the shape comes from 2 of the wedges. The height of each wedge is the radius of the circle, so h is equal to r. b is made up from the bottom half of the circle, so it is half of the circumference, which is 1/2 of pi times d. We can rearrange this to be pi times half of d, which is useful because we can replace 1/2 times d with r. So our height is r, and the base is pi times r. If we use 8 wedges instead, we still have a height of r and a base of pi times r. The same holds true for 16 wedges, 32 wedges, and 64 wedges, and we could keep going. We can imagine using more and more wedges and realize that with infinitely many wedges, our shape is now a rectangle, which is the same area as the circle. The area of the rectangle is base times height, which becomes pi times r times r. Removing the brackets, we get pi times r, which we can write as pi r squared. So the formula for the area of any circle is pi times r squared. Let's apply what we have learned about the area of circles with some problems. In this first problem, you are asked to determine the area of each blue region. To answer questions like these, we need to know some measurements. So let's say the first circle has a radius of 10 centimeters, the second circle has a diameter of 30 centimeters, and the third circle is a combination of the first two circles. How do you think you can determine the area of each blue region? For the first circle, we can use area equals pi r squared. The radius is 10 centimeters, so the area is pi times 100, which is 314 square centimeters. For the second circle, we first need to realize that the radius is half of the diameter, so it is 15 centimeters. So the area is pi times 15 squared, which is pi times 225, which is 706.5 square centimeters. Notice in the final image, the blue region comes from taking the center circle away from the larger circle. So the area of this blue region is the difference between the areas of the two circles. This amounts to 392.5 square centimeters. For this final example, we'll be comparing pizza prices. A medium pizza has a diameter of 12 inches and costs $7.99. A large pizza has a diameter of 14 inches and costs $10.99. Which do you think is the better deal? Let's compare the areas of the two pizzas. The first has a radius of 6 inches, so its area is 36 pi square inches. The second has a radius of 7 inches, so its area is 49 pi square inches. With all this information, there are many different ways we could make a comparison. Here's one way. Comparing the areas, the large pizza is about 1.36 times the size of the medium pizza. If we apply that ratio to the price of the medium pizza, that will tell us what the large pizza would cost if we were at the same cost rate as the medium pizza. That product is $10.87, which is less than the cost of the large pizza. So in this case, the medium pizza is actually the better deal. Another way we could have compared the pizza deals is to compare the cost per square inch. The cost per square inch of the medium pizza is less, so the medium pizza is the better deal. This video addresses several learning standards in the Mathematics Grade 7 curriculum. The constant ratio referred to in this big idea is the number pi, in which we use to measure and compare circles. In content, we looked at the circumference and area of circles. Several curricular competencies may emerge as your child learns about circles in their classroom. There's a lot of mathematical vocabulary developed to be able to describe and solve problems involving circles. How to calculate the circumference and the area of a circle were concepts developed through inquiry and reasoning, and these ideas were then applied to solve problems. Finally, visualization was an important part of exploring the concepts, especially visualizing how the wedges of a circle come to form a rectangle. We hope that you found this video valuable in helping you support your child in their learning about circles. Be sure to check out the other titles in this series.